Before I do this question, first I will tell you few basic things. To understand the few basic concepts, see this thing. Suppose an equation 13x minus 17y equal to 5 is given to you, and it is given that x and y are both integers, and you have to find all possible integral solutions of this equation. One way of doing this question will be with the help of common sense, and because with the help of common sense it is not sure that you will be able to solve the question. Afterwards I will tell you the standard way of doing the question of the type when the equation is a linear equation in two variable and you have to find the all possible integral solutions of this. Note that I am saying that x and y are both integers. The common sense way is, if you are able to find even one solution satisfying this equation using your common sense, then you can find all the integral solutions of this equation very easily. And if you apply your common sense, it is easy to see that x equal to 3 and y equal to 2 are satisfying this equation, because it will be 39 minus 34, that is 5. If one solution is known to you, you can find all the solutions of this equation very easily. How? See, write the constant term as 13 into 3 minus 17 into 2. Hence we get 13x minus 17y equal to 13 into 3 minus 17 into 2, and I get 13 into x minus 3 equal to 17 into y minus 2. And now we can write it as and writing it equal to say n, I get x equal to 3 plus 17n, y equal to 2 plus 13n. Or directly also you can write in this way also, x equal to the number you had got 3, and looking at these coefficients, this coefficient write in the value of x, this coefficient write in the value of y, and change the sign of any one of them. Here minus 17 has come here, 13 has come here, and you may be thinking that I could change the sign of 13 and keep minus 17 as it is, then I will get different solution. That is, if I change the sign of 13 and keep minus 17 as it is, I will get 3 minus 17n and y equal to 2 minus 13n. But note that these two solutions are only seemingly different, they are same. If I put n equal to 1 here, or I take n equal to minus 1 here, you will be getting the same solution. If you put n equal to 2 or you put n equal to minus 2 in this, you will be getting the same solution. Hence both are correct, and this is the general solution of this equation. That is, I mean to say, go on putting the integral values of n, you'll go on getting the values of x and y, and every ordered pair of the type xy, where the value of x and y has been obtained from here, every ordered pair will satisfy the given equation. In this way you can find infinite number of integral solutions. Note that in case HCF of this and this is not able to divide the constant term, in that case there will be no solution. Without doing any calculation, immediately we can say there is no solution. For example, if I say 12x minus 14y equal to 21. Clearly the HCF of these two numbers is 2 and 2 doesn't divide the constant term, hence this equation is not solvable in integers. That is, there is no any integer value of x and y which can satisfy this. But for this way, the main problem is using your common sense. You have to write constant term in terms of 13 into some integer minus 17 into some integer, and by common sense way it is not sure that we'll be able to do the question. Hence now I am telling you the standard way of doing the questions of this type, in which you are not able to think the value of x and y. And now I am going to tell you the concept of Diophantine equation. Agreed, it is not in the syllabus of JEE Main, and because the question has come in JEE Main and common sense way doesn't give the guarantee that you will be able to solve the question. Hence I am going to tell you what is the standard way of getting the integral value of x and y, which getting all the integral values of x and y which will satisfy this equation. The standard way is, out of these two, whichever is bigger, take that number on right hand side. Note that I'm just considering the number, sign is not important. Out of 13 and 17, because 17 is bigger, take 17y on this side. 13x equal to 5 plus 17y. After that, divide by coefficient of x. X equal to 5 plus 17y by 13. And afterwards, try to make the coefficient of y as small as possible. And further we'll be trying to make the constant term and coefficient of y as small as possible. 5 plus 4y by 13 plus y. And further, suppose
Agreed, whatever I am telling is standard way of finding the general solution of a Diophantine equation, but afterwards I will tell you the shortcut way of finding the general solution also without using the common sense way.
this as some other variable, say u, write 5 plus 4y upon 13 as u. We get y equal to 13u minus 5 by 4. Again make the numbers in the numerator as small as possible. Hence y can be written as 3u plus u minus 1 by 4 minus 1. And once we have got the coefficient of variable 1, the main part of the question is over. What you will do now, you write u minus 1 by 4 say equal to v, and now I will get the value of x and y both in terms of v. See how. Clearly u is equal to 4v plus 1, and now put this value of u here. You will be getting y equal to 3 into 4v plus 1, and this is already supposed as v minus 1, hence we have got 13v plus 2. And now put this value of y in this equation. You'll get x equal to, it is not necessary that this value of y you put in this hole and calculate it. Better is, because this is already supposed as u and y is 13b plus 2, it is 13b plus 2, and u we have already found 4b plus 1, hence we get x equal to 4b plus 1 plus 13b plus 2, that is we have got x equal to 17b plus 3. Previously also we have got the same answer. And one thing more I would like to tell you is, if in the middle of procedure, if you are able to find any integral value of y, then it is not required to proceed further. Just immediately you can stop there and get the solution very easily. See what I mean to say. You can see very easily, if I take u equal to 5, the value of y will become integer. Hence, I get the value of y as 3 into 5 plus 1 minus 1. I have taken the value of u as 5.
Actually, I had forgot. It would have been better if I had taken u equal to 1.
It is not necessary that you can take 5 only. Even if you take u equal to 9 also, then that is also correct. Yes, it will happen that by taking the value of u equal to 5 or u equal to 9, the values of x and y you will be getting will be different, but they are only seemingly different. Actually those are same. What is the meaning of my statement, you will understand when I will complete this. Now I have got the value of y as 15, and now put this value of y here and get the value of x. X is equal to 5 plus 4 into 15 by 13 plus 15. I get the value of x as 5 plus 15, that is 20. And as I told you in the very beginning, that if you are able to find even one value of x and y which satisfies this, you can immediately get all the solutions of this, because presently I have got the value of x as 20, y as 15, hence the value of x will be 20 plus 17n, and y equal to 15 plus 13n. As I told you that change the sign of any one of them and use a coefficient and use this number in x and this number in y. And now these values of x and y are different from this value of x and y. You may be thinking, but no, they are not different. You can see very easily, if I take n equal to 1 in this or n equal to 0 in this, the values of x and y will be same, because n is any integer. Go on putting the values of n, go on getting the values of x and y. Or if I put n equal to minus 1 here, the value of x and y you will be getting will be 3 and 2. Or you put n equal to 0 in this, you'll get the value of x and y as. And as I have been always promising that my solutions are crystal clear, therefore for clarity purpose, let me make you this concept clear with the help of one more example. For example, one more question I am giving you to solve is 25x plus 11y equal to 2, and I say find all possible integral solutions of this equation. It is easy to observe that if I take the value of x as 3 and y as 7, the numbers you will be getting will be having difference 2. Therefore, immediately we can say that x equal to minus 3, y equal to 7 satisfies this. And if even one solution is known to you, you can get all the solutions by taking the value of x as minus 3 plus 11n and y equal to 7 minus 25n. As I told you in the previous way also, you have to interchange the coefficient in the value of x and y. That is 11 you will be writing in the value of x, 25 you will be writing in the value of y, and changing the sign of any one of them. That is, I could write in this way also, x equal to minus 3 minus 11n and y equal to 7 plus 25n. This solution is not different from this solution. It is clear that if I take n equal to 1 in this or n equal to minus 1 in this, the answers will be same, and because n is any integer. Hence these two solutions are only seemingly different, they are not different. But because common sense way is not always easy to bring in mind, therefore I will do this question by standard way also. Agreed, I am going to explain the same thing as I had explained in the previous question. Hence, those students who had understood the previous question, it is not required for them to see the solution of this part, but for crystal clarity purpose, I am doing this question once again by the standard way also. As I told you in the previous way, we always take the term with higher coefficient on right hand side. Note that when I am saying the word higher, I just have to see the numbers without sign. Had it be minus 25x also, I would have taken this on right hand side. That is, I get 11y equal to 2 minus 25x, and y is equal to 2 minus 25x upon 11. As I told previously also, we will try to make the numbers in the numerator as small as possible. We can write it as y equal to 2 minus 3x by 11 minus 2x. And as I told previously also, even in the middle of the procedure, if you are able to find the integral value of x and y satisfying this, you can immediately stop there, and because you have got the integral value of x and y satisfying this, immediately, as I told you, if even one solution is known to you, you can find general solution in this way. See, it is clear that if I take x equal to minus 3, then the value of y you will be getting as integer. That is, I am taking x equal to minus 3. I get the value of y as 1 plus 6, that is 7. It is not necessary that I should take the value of x and minus 3 only. You can see very easily I could take the value of x as 8, then also this whole will become integer. And if I take x equal to 8, the value of y I'll be getting will be minus 2 minus 16, that is minus 18. And hence, by taking this value of x and y, the solution I'll be getting will be x equal to 8 plus 11n and y equal to minus 18 minus 25n. You can see very easily this solution is not different from this. They are actually same, only they are seemingly different. It is clear that if I take the value of n as 1, the solution I'll be getting here will be same as if I take the value of n equal to 0 here. For n equal to 1 or n equal to 0 here, the values of x and y will be same. And because n is any integer, hence this set of solution and this set of solutions are not different. And next thing is, suppose in the middle of procedure you are not able to think this thing, then proceed further and go on making the coefficient of x as small as possible. See how I'll proceed further if this thing you are not able to think. You will be supposing this as, say, u. You get 2 minus 3x by 11 equal to u. I'll be getting x equal to 2 minus 11u by 3. Again, to make this coefficient smaller, write x as 2 minus 2u by 3 minus 3u. That is x equal to 2 into 1 minus u by 3 minus 3u. Now it is very easy to think that u equal to 4 makes the value of x as integer.
Here again, it would have been better had I taken the value of u as 1.
That is, for u equal to 4, the value of x you will be getting will be minus 2 minus 12, that is minus 14. And now putting this value of x in this value of y, you will be getting y equal to 2 plus 42 by 11 plus 28. That is the value of y I have got is 32. And now after getting y equal to 32 and x equal to minus 14, the value of x and y becomes x equal to minus 14 plus 11n and y equal to 32 minus 25n. Previously we had got this thing. That is, I had got previously x equal to minus 3 plus 11n and y I got was 7 minus 25n. Clearly these two solutions are only seemingly different. Clearly if I write n plus 1 for n, I'll be getting this thing. Or in other words, it is clear that for n equal to 0 here or n equal to minus 1 here, you will be getting the same solutions. That is, I mean to say, this set of solution or this set of solutions are not different. And now I'm going to do this question according to language of the question. This is a rhombus. This is the point P R Q S, because the rhombus given to you was PRQS, and according to given information the point P is -2, -1 and 1. The point Q is 56 by 17, 43 by 17 and therefore direction issue of PQR 56 by 17 plus 2, 43 by 17 plus 1 and 111 by 17 minus 1. That is, I get 90, 60, 94. Or we can also say 45, 30 and 47. It is given that direction ratio of RSR alpha -1 and beta. That is, this has direction ratio alpha -1 and beta. And because it is given that the figure is a rhombus, and in a rhombus diagonals always are perpendicular to each other. Hence, using these direction ratio and these direction ratio, we can easily say that 45 alpha minus 30 plus 47 beta equal to 0. That is, I get 45 alpha plus 47 beta equal to 30. And he is saying alpha and beta are integers of minimum absolute value, then alpha square plus beta square. First of all, I will find the integral solutions of this equation, and then I will choose the minimum absolute value of alpha and beta. As I had explained in the very beginning of this question, first I will take the number with higher coefficient on right hand side. I get 45 alpha equal to 30 minus 47 beta. Also, it is not difficult to think why I am taking the number with higher coefficient on this side. And after that, alpha is equal to 30 minus 47 beta upon 45. That is, alpha is equal to, and next step is I will try to make the numbers in the numerator as small as possible. Therefore, I would like to write 45 minus 15 minus 45 beta minus 2 beta by 45, and hence I will get the value of alpha as 1 minus beta minus 15 plus 2 beta by 45. And as I told you in the very beginning also, if even in the middle of the procedure, if you are able to find the integral value of alpha beta satisfying this, you can immediately stop there. You can see very easily, if I take the value of beta as 15, then this will become integer, hence the value of alpha will also become integer. And if you are not able to find at present stage, you can also proceed further by taking 15 plus 2 beta by 45 equal to, say, gamma. And again, now beta is equal to 45 gamma minus 15 by 2, that is beta is equal to 22 gamma minus 7 plus gamma minus 1 by 2. And now it is very easy to find the integral value of beta. It is clear that if I take gamma equal to 1, I will get the integral value of beta, and the integral value of beta will be 22 minus 7, that is 15. Yes, I could take the value of gamma as 3 also. That's not a problem. But the solutions you will be getting will be only seemingly different, not actually different. See, for example, if I take gamma equal to 3, beta equal to 22 into 3 minus 7 plus 1. Agreed, it is not good to take gamma equal to 3. Just for clarity purpose, I am telling you that you could take the value of gamma as 3 also. I will prove that finally the values of alpha and beta I get by using these steps or by using these steps. They will not be different, they will be only seemingly different, as this thing I have explained in the concept of introduction also. And once the value of beta is known to you, you can get the value of alpha also. That is, now put beta equal to minus 15, you'll get alpha equal to minus 14 minus 15 plus 2 into 15 by 45. That is alpha equal to minus 14 minus 45 by 45, that is minus 15. Hence the value of alpha you have got is minus 15, and the value of beta also you have got equal to 15. And as I told in the very beginning, the general solution of this equation will become alpha equal to minus 15 plus 47n, and beta equal to 15 minus 45n. Recall that I had told you that you write the coefficient of alpha in beta and you write the coefficient of beta in alpha and changing the sign of any one of them. Agreed, I could write minus 15 minus 47n and 15 plus 45n. That is also correct. The whole explanation I have already given in the concept of introduction part. And because he was telling us that alpha and beta are integers of minimum absolute value, you go on putting the integral value of n, you'll go on getting the values of alpha and beta satisfying this. But because I have to find the minimum absolute integral value of alpha, hence I take n equal to 0, and therefore I will get the value of alpha as minus 15 and beta is equal to 15. Just because I want to make my solutions crystal clear, therefore I am proceeding this thing. Had I taken the value of beta, this beta equal to 66 minus 7 plus 1, that is beta would have been 60. And after putting the value of beta equal to 60, I will get the value of alpha as 1 minus 60 minus 15 plus 120 by 45. Alpha will be 1 minus 60 minus 3, that is the value of alpha will be minus 62. And recall that I had got the value of beta as 60, and hence by using this value of alpha and beta, the general value of alpha will be minus 62 plus 47n, and beta equal to 60 minus 45n. Recall that I could write minus 47 here and plus 45 here also. That was also correct. And because I want to find the minimum absolute value of alpha and beta, it is clear that if I take n equal to 1, the value of alpha and beta you will be getting will be least in absolute value. Alpha becomes equal to minus 15 and beta equal to 15 by taking n equal to 1. And once alpha and beta are found, the value of alpha square plus beta square, the value of alpha square plus beta square becomes minus 15 square plus 15 square equal to 450.